Hello and welcome to our today's discussion. All right, so today we want to discuss a contactor, of which a contactor is a mechanical switching device that is capable of making, carrying, and also breaking electric current. To achieve this, it is done under normal and also overload conditions, of which for overload conditions, this is done using an overload. And so basically, contactors are designed according to the method of energizing, which can either be electromagnetic, pneumatic, and also electropneumatic. So like for our discuss, we're looking at the electromagnetic. So this electromagnetic conductors are in different sizes. Okay, we have 24 volts, we have 110, we have 220, we have 380. Okay, and so when you talk about 24 volts, it means like here, this is the A2, and this is the A2, and we also have a single A1. It means that on our A1 we supply our live, and on our A2 we supply our neutral. But looking at the contactor that we have, this is a 220 volts contactor, so it is imperative for you to check the size of the contactor before you even do your installations. And so here we have L1, and also we have the T1 here corresponding. These are normally open contacts. And so when this contactor energizes, it means it closes these normally open contacts. And then 13 and 14 here are used for hold-on contacts. If you remember, in our previous design, in our previous video, we checked that for this contactor to hold, this plunger for it to hold in the position like that, it needs a hold-on contact. And so 13 and 14 are the contacts that we use for hold-on contact. No wonder we are saying that contactors are made to design and function according to how we want us to achieve. In an event where we'd want to use a single phase, maybe it is 220, or maybe it is actually 110, or maybe 24 volts. Okay, so the difference between contactors is that we have AC and DC contactors. So a DC contactor, it operates using an electromagnetic coil to control a high current DC current, of which this happens in a state that once we supply power to the coil, the normally the movable contact are able to close. Okay, so meaning the principle still remains. The normally closed will become open, and the open become closed. And so the process is crucial for switching heavy loads in DC systems, because we need to distinguish systems designs that are able to handle more difficult arcing in DC circuits compared to AC. Knowing that in DC there is always a concept of commutation, and so it is important for us to achieve a design, meaning like we have for DC, that will be able to help us do the work that we desire. Also, the other difference is that for DC contactors, control voltage applications process actually begin when we apply a voltage that is to our contactor, and then it goes to the electromagnetic coil, where the current will now flow through to create a powerful magnetic field. And once this is done, it means normally open contacts are going to close, and thereby allowing power to flow to our load. And so here, the closing of the main contacts actually will create a low resistance path, creating the circuit and allowing high current DC to flow to the load and also be able to control. All right. So when the voltage, the control voltage is removed from the core, the field definitely, is going to collapse. And we have an application of the clapper contactors, of which these clapper contactors, they are designed for good vibration, that is in terms of maintaining, and also they are strong. And also the design, they have a moving clipper arm, which makes them suitable for applications where we need to easily maintain and also the switching of a DC power circuit. And also, it is important to know that an AC contactor operations, it actually hinges on an electromagnetic coil, like we had earlier mentioned on DC. But the major difference is that, quite right, yeah. Once we supply the voltage, then we are going to have a creation of a field. The creation of a field where the plunger will be held into position using a Holland contact. But once we remove the voltage, then we are going to have a collapse in the field. And then the spring in the contactor is what is going to help us return the normally open uh, back to their normal original state, and also the normally close. And so the major difference is that for AC, they have both magnitude and direction, but for DC, it has only direction. And so when we talk about arcing that actually happens in DC, since it doesn't have a zero crossing, so arcing will actually happen more. And so no wonder we are saying that AC contactors are for alternating current, yes, and use laminated cores to handle high inrush currents and shading cores to prevent harming. And then DC contactors are for direct current, yes, and use solid iron cores and magnetic arc extinguishing mechanisms, because DC don't have a zero crossing to extinguish these arcs. And so the other difference is that when you talk about the power type, for AC contactors, there is a periodical change that happens, that is in direction, but for direct current, there's no that change. And for the core design, for SC contactors, we have elimination of ion cores, which is meant to reduce eddy currents and also hysteresis. But for DC contactors, we use solid cores because eddy current and hysteresis losses are not a factor to be considered in a DC circuit. And when you talk about arc suppression for AC contactors, they rely on a shading core to keep the magnetic field energized and use the natural zero crossing of the AC wave to help extinguish the arc when contacts open, while DC contactors require more robust, strong magnetic arc extinguishing mechanisms due to the continuous current. And so is the difference between these two. And the other one is also on the concept of construction. AC contactors have a thicker coil to handle high inner current. Since we know that when there's a lot of resistance, the amount of current that is being received becomes reduced. And so for DC contactors, they use diodes, all right, to release the stored electromagnetic energy when the core is de-energized. And the main use of these diodes, since we know that they're forward biased, it means that they are going to prevent an effect of back EMF. All right. Some of the applications for AC contactors is where we are using the AC motors, the lighting systems, and other AC powered devices. And if you realize the certain industrial stoves, yeah, when you talk of machines that use AC contactors, but for DC, even overhead cranes, we are able to use them, okay, and other industrial applications that require basically the use of a DC control circuit. So I wanted to make that distinction so that even as we are going to continue doing our designs, we'll be able to differentiate. So for our designs, we're going to be using the AC contactors. Thank you.